Now we move on to problem number 4. And here's what we're going to do. Let's assume, oh no, I just want to write on my laptop. Let's assume this direction is positive. And now let's do some free body diagrams. So for mass number 1, we're going to have a tension going up and its weight pointing down. And for mass number 2, it's actually an identical free body diagram, but it's the sign convention that makes things weird. See, for mass number 1, the tension is a positive force and the weight's a negative force, whereas for mass number 2, the sign convention flips because we're saying that clockwise is the positive direction. Oh, physics, you saucy minx. And that's okay that I said that because it's actually Shakespeare. So there we go. It's probably not okay. Context is everything, right? Okay. Let's do the equation for M1. So we're going to say the tension force fights the gravity. And the effect is that M1 accelerates. Oh my gosh. And then for M2, this is where the sign convention matters, equals M2A. Now I'm going to solve for the acceleration by adding these equations together. Check this out. When I do that, I'm going to get M2G minus M1G equals M1 plus M2 times A. So what I get is that the acceleration equals M2 minus M1 over M1 plus M2 all times G. That's all very well and good. And now let's go ahead and get that tension using the numbers, or using the letters. You notice I don't put a single number into these formulas. I'm rather proud of myself for that. All right, now let's get the tension. M2G minus FT equals M2 times, M2 minus M1 over M1 plus M2 times G, yeah? All right, now let's get some common denominators going in a second. So here's what we're going to do. We're going to say M2G, M1 plus M2 over M1 plus M2, just multiplying that. And then I'm going to bring this over to the other side by subtracting M2 squared minus M1 M2 over M1 plus M2 times G. That's actually what the tension is going to equal. We got quite a bit to simplify here. Let's do it. So what I'm noticing is M1, M2G, that cancels. No, that doesn't cancel. That actually adds up. So the M2 squared cancels, the M1, M2 doesn't. So I end up getting that the tension is 2 M1, M2 over M1 plus M2 times G as my tension force. Such a delicious problem. So that's questions 3 and 4, and I hope that that helped you get the homework done. You should definitely expect questions like this on the real test.